I'm Dave. Welcome to another steam powered machine shop. Today I got some clips put together of making a new piston for the Liley steam engine out of a casting that I had Cattail Foundry make up for me this spring, and some other little details, and we'll get right going along to it. I'm getting the boiler ready to fire up this spring, and the New York State boiler inspector stopped by this morning and everything passed okay, but he wants me to replace this fusible plug. Which is right there, you can see it. It's screwed into the flue and this one's been in there about 5 years, although New York doesn't have any particular code rule on how often they should be replaced. He wanted it replaced, so we don't question authority. And you can see what it looks like. ASME standard, but no date. The Pennsylvania boiler guys file a notch every year in your fusible link. When you get 4 notches, you got to replace it. So I'll get one of these to order up. I cleaned this up a little so you can get a better look at it. Now these are screwed either into the flue sheet or the in the case of a vertical fire tube boiler, they're actually screwed into the one of the flues on the water side, and if the water gets down below this plug and it overheats, this softer metal here in the middle melts out and it blows steam into the tube out the top and down the bottom, and it's not really intended to reduce the pressure or solve the problem. It's more of a warning device, and it's claimed that this woods metal in the middle here, it's sort of like solder, the temperature that it melts at changes with age, so that's why they want you to replace them every so often. And this one has been in there about 4 years, 4.5 years maybe, and I'll be replacing it. They call this one a water tube side or water side fusible plug. Now in a conventional type boiler, like a locomotive, this would be screwed from the firebox into the flue sheet. That's called a fire side plug, and it's like turned around the other way. So this is a water side plug, and it's 3/8 pipe thread. So we'll get some new ones. Got the casting for the piston set up in the chuck, and I'm going to face it off. That spot right there is really hard. I'm going to make a design change on this piston. The original piston here was at a straight hole for the piston rod, and you know, the sun coming through this window is really rough. Maybe you can see this had a shouldered, diameter with a shoulder on it. It was pressed into that, and on the other side it protruded slightly, and then the end of it was cold forged into a kind of a chamfered hole. Well, it worked all right, I guess, but that's not the way that better engines were built in its day. So I'm going to bore this and bore it with a taper, probably a Morris taper, if the size works out right. It doesn't really matter, any long taper would work, and then match the piston rod with a taper. Thread the end of the piston rod so this goes into the taper, and it's countersunk on the other side for a thin nut, and it'll be flush with the side of the piston. Make it a little better setup, really. taking a few cuts off this piece of 2-inch pipe to clean up the OD on it, to make a mandrel for the main bearings to be poured on the steam engine. Okay, here's the plan for the piston. I'm going to drill this and put this taper in here. The piston rod is 7/8, and I want to neck it down here to 3/4 with a nut recess. So if you set that up as a little triangle here, it's got to go an 1/8 inch over 1.760 actually, so that's a 1/16 on a side, so it's got to go 0.62 in 1 3/4. So I set that up on the compound on the lathe. I didn't show you this because it's kind of small stuff, but anyway, the compound set up. I put a dial indicator over here and ran 1 3/4 and kept monkeying around with the compound until I got it to go just 62 thousandths. Then I put a boring bar in here and bored my hole out so that this is the big end. The small end is in here. So this is roughed out. It's got roughly got 125 to go for final OD. This is finished. So now I'll turn the casting around in the chuck here and face this other side down. Okay, I got her turned around in there. I got it indicated in with my trusty Belay 1910 dial indicator. And I've got a kind of a beat up carbide tool in there because this outer skin on here can be pretty hard at times. So I'll get through here a little ways and probably switch back over to a high-speed steel tool. We'll take the speed slow and the feed heavy. Oops. I got to lock up my spindle. I think I'll run into the back here. That would be better. good. I just stay with that for a bit. So got a Okay, the compound is set up here to give an angle of 62 thousandths over 1 3/4 inches. I set it up with a dial indicator. It's not much of an angle. Very shallow taper. On center. Okay. Okay, now I'm test fitting it. Feels like it's contacted all the way along the table. Tighten that nut up, man, and it's gonna stay on there tight. Now, determine where the end of the thread comes and thread the end of the 3/4 national course thread. Okay, 10 threads per inch. I got the 60 on the bottom here, so you're using the lower scale. And 10 is in this notch. And it's BBC. B, C, threads. That should do it. Well, I turned it around and set it up in the lathe, and on this end of the rod I turned a 7/8 by 9 thread, and this is the old nut. I'm going to get a new nut for it, and this screws into the crosshead. It's just a little bit tight, but I think I may run a die down on it just to final size it. I want a really close fit in the crosshead. There you go, about 8 ton. Got to take small cuts because it's wanting to chatter. Got a real sharp pointed tool and I'm running it fairly slow and it's doing pretty good right now. This has to be turned 5 thousandths smaller diameter than the cylinder's bore. tube is 3/8. So that's exactly what we want, 3/8.